Let's welcome Richard to the stage.
All right. Thank you. Well, started off with my first crowd work question, which is, have you heard of Goose? It seems like one person. Okay, we have another person who's actually heard of Goose. So I'll give you quickly who I am. I'm a tech lead at Block. I work on the DevRel team. I've been there for about 8 years. Most of my experience has been on API design, API development, and promoting those. Now I'm just 100% all in on AI, like I think a lot of people are these days. So Goose, I had to drop the code name because I think we're actually trying to shift to just Goose, but we still lovingly call it codename Goose. So since you don't know what Goose is an open source AI agent that runs locally on your machine. So you're probably familiar. How many of you are actually using coding agents of some kind? I had a very strong feeling. Are you using all right, how many people are using Claude Code? Okay, how many of you are using Cursor? I love seeing all the overlap between all of these tools. It's like, I could probably name like 5 other tools. You probably all raise your hand. I mean, why not? So Goose is free and it's open source. And so that's like easy to say, but what that actually means is that you can literally go clone it, you can extend it, you can use it for any purpose. We're currently using it throughout the entire internal part of Block. And we found it to be immensely useful. We built it because it started as a passion project really early on. We were collaborating with Anthropic on the MCP protocol. We ended up realizing that having an agent was going to be immensely helpful, but we also really liked it being able to use any LLM model out there. And I think that's a very key differentiator for Goose compared to a lot of their tools out there. A lot of their tools are very vertically integrated. Claude Code's going to work great with Anthropic models, but then GPT-5 comes out, and like we all have to go switch to the latest best model. Goose doesn't have this problem because you can actually just go use any LLM provider, connect it in, and continue coding and switching between different tools. It also, of course, it runs locally, but that also means that you can deploy it anywhere. So you could be running it in a GitHub action, a Docker container. We have them running in our CI/CD pipeline. We even have a version of this that's actually running as a Goose like Slack bot that we can actually just pull into the context of a Slack thread and have it start working on stuff. It also operates as an MCP client. So what that means is that you can extend Goose using any MCP server. We like to think of it as like a tool that you can use for every part of the software development lifecycle, not just for code generation. So there's 2 different formats that you can use Goose. These are effectively function the same. There's just slight variations. So there's a desktop client, and then there's a CLI client. They're both using the same underlying binary. You can think of as the desktop client as like an Electron wrapper that's still going to be talking to the same underlying tooling. You will notice some key differences between the two. I would say that the CLI tends to be slightly ahead of the UI in terms of feature development, mainly because certain features don't translate well from a CLI into a UI, because there's a lot more design work that has to happen on this side. So basic architecture of this, you have your interface, that's going to be your CLI or your desktop app. And then there's the agentic loop that's actually like running through the prompts and calling through the different tools and trying to like iterating through that. And then we have our extension system. Extensions are just MCP servers. We call them extensions because for people who are non-technical, that's a little bit easier to understand than an MCP server. Because I think most people are going to think, why do I have a server running on my machine? So it's easier to just refer to them as extensions. So you can extend it. We have lots of extensive documentation of all of these different MCP servers that you can install into Goose. But you're not limited to this. This is just what we've decided to make easier for people to understand how to install them. And I will give you a couple quick tips about Goose because we're going to be actually using Goose very shortly. A lot of these are what I would consider generally useful tips when using coding agents. I think that it's generally useful to converse naturally. You don't need to be like using a very structured language most of the time. You can also choose the right LLM for the task that you're actually trying to do. Right now, we're going to be using basically just Claude Sonnet 4.5. I wouldn't really try to use a whole lot else. But the other most important thing is maintaining short sessions. How many of you are familiar with context engineering at this point? I've heard of it. Okay, some of you have heard of it. I will be talking a little bit about context engineering because we're going to be going through sub-agents and like how to leverage them in an effective way. So I will really quickly just show you Goose. I have to exit out. Oh, that's because it's the left. So here on the left, we have the desktop client. And then on the right here, we actually have the CLI. I'm going to make that a little bit bigger. So I'm actually going to fire up Goose, and we can actually just ask Goose, like, tell me what we're going to work on. I'll be honest, a lot of the time I'm actually using like a Super Whisper or something to do this. So actually having to type is a little bit slow. But you can see that, we just fire off a prompt, and then it's just going to start running through the agentic loop right now. Right here, it's just going to hit it to my LLM provider. Right now, I'm pre-configured with stuff that's through my work. They have us pre-configured with like Databricks to do all of our different model selections. We're going to actually have you guys going through a different way to connect through OpenRouter. But you can see that I already have this seeded with some Goose hints. You can think of Goose hints as like similar to cursor rules or agents.md. It's kind of like your project specific, or you can have a globally configured rules of how you want Goose to operate in a given context. So I already seeded this here to tell it what we're going to be working on. And that's kind of like just like the quick showcase of Goose. So let's actually go back. And then the first thing I want us all to do now is install Goose. So you can use, there's a QR code there for you to actually, if you want to like follow up later. There's a short URL there. That's actually just going to take you directly into the documentation to go download Goose on your machine. It should run on any machine because it's supported on both Mac OS, Linux, and Windows. If you're running into issues in installing this or running it, please let me know. So if you already have that, the wrong one. The next step, and this is actually more important, it's free LLM credits. So you can actually go to this short URL. You're going to land on a page there. It's going to ask you for an email address. I will assure you, I'm not going to be emailing you. We actually don't want to email you. This is just so that when we're giving you an API key, we can track who we gave an API key to, so that we're not issuing a bunch of API keys, because I don't know that we have an unlimited marketing budget. So go ahead, go to that link. I would highly recommend, if you're going to do it on your phone, if you have a way to actually transfer it over to your machine, because after you actually pull that up, it's going to give you an OpenRouter API key. And then that's what we're actually going to be using when we configure Goose to actually connect it and then be able to use those $20 worth of cloud credits, well, LLM credits. Cool. Keep hitting the escape key. I'm so used to using a different presenter. So in order to configure Goose for this particular session using that API key, the important thing you need to know is you're going to be really tempted to click like Anthropic or OpenAI or one of these other LLM providers that you're super familiar with. Do not click on those. You want to click on OpenRouter, because that's what the key is for. So you're going to want to go on OpenRouter, and then you're actually going to add the API key in there during the configuration, and then you click Save and Launch. I would demo this for you, but because I'm on my internal version of Goose, I literally have no other option than Databricks. So if any of that's unclear, you run into an error, please let me know. I'm happy to just come over and help resolve it. I know every once in a while somebody has like a 401 or some oddball type thing, so just let me know.
Raise your hand if you have an error.
OpenRouter account already? Can you just use that? Or?
So I don't think so, because you're just going to basically configure. I mean, you could use OpenRouter yourself, but the problem that you're going to have is this API key is tied to like where the credits are on there. So you're going to want to just like plug this in. But I would say that later, after those credits run out, you can totally just replace it with your own Open Router API key.
Any other questions?
And just, you know, it's very important that you actually go generate your API keys now, because we don't keep that whole interface open all the time. But the credits that you have will continue to remain valid. So you generate a key now, you can continue to use those until they run out. Sorry, what's that? I think it's, don't hold me to this because I know somebody like might have tweaked it. I think it should be $20 on there. I don't know if we've adjusted that since I mean, most model prices have stayed relatively stable. So I'm going to plug a couple more advanced features that we have with Goose. I am actually very happy to say that subagents is now officially supported. This was in alpha for quite some time. Sorry, was there a question?
But I think, how do you, I'm getting a page where it says $10, $25, $50, select credit amount. What do you,
Bottom link it says free. The very bottom says, I'll go with the free ones.
oh, okay. Oh, sorry. Okay, sorry.
No worries. We're here to make sure that everybody gets to have some fun with Goose right now. So just going to mention some of these things. These officially supported as subagents. This actually was an experimental feature up until like, several weeks ago. We're also one of the first clients to actually support MCP UI. How many of you know what MCP UI is? Oh my gosh. I wish I did this whole entire workshop on MCP UI. MCP UI is a new feature that is being made available in the MCP spec. And it basically allows you to render UI directly in an MCP client. There's a really great demo by the creators of MCP UI. If you look up, I think it was on MCP Night 2.0 or MCP Dev Summit. There's definitely a couple different talks, but they basically showcase rendering a checkout flow from Shopify in an MCP client. So there's actually ways for you to create UI components to create an entire flow directly in an LLM agent. In addition to that, we will be mentioning recipes. This is actually a particular sort of workflow that you would actually create using Goose. We're actually going to run those recipes as subagents in this particular example. And I always like mentioning headless Goose, which I know sounds weird because you don't want to think about a goose without a head. But this is actually just sort of running in this automated environment. So we run a version we call the headless Goose that is running in our background. So when I create an issue or a PR within my company and I tag this Goose, it's actually running in a headless mode where it was just going to run through a specific prompt sequence and then push back a response on my thread. So with that, that is trying to go through all the various housekeeping parts of this. Let's actually go into the desktop client is failing for you. Let me come over there really quick and I'll take a look.
Anyone else having troubles?
If you open up your terminal, yeah, I've run into this one time before. If you open up your terminal really quick, we can find out. Kind of hacky, but so if we could change directories into your downloads folder. Sudo try to hit them.
I mean, I
What
just
I'll
have
do is
this
I'll
page
kick
open,
off
so we need it later.
and I'll come back.
This is the.
I have a quick question.
Things happen occasionally. If you go to the Goose docs, there's an issue about.
All right, we have a few questions mounting up. If you
Sure. Okay. Do you have a question?
Do I have to go to through this titrate agent router service to install?
No, you should not need to do that.
Why is it?
Yeah, you want to close that out.
Yeah.
Then you can actually just go back to like other providers, like do the.
Yeah.
And then go to open router through there to put the API key in.
Thank you.
It's on the Windows you're using. Yeah, I don't know why that worked. Anybody else? Connecting? Question?
I think I have it. Cool. We're ready to roll.
All
Oh,
right.
wait, there was one more. Did you? You got it. Sorted it out.
Fully outsourced payroll, like a BPO company.
I think I realized that there's like a new onboarding flow that I did not like double check on where it had like the tetrate and then like automatically configured through Open Router. I think you probably for this flow want to go through other providers, then go to Open Router.
That's what I did too.
And then put your API key in.
All right.
Really useful feedback that I'm going to give to this team.
Ready to roll. Cool.
Cool. So how many of you are familiar with subagents and how they work? When to use them? Not at all. This is so great. Okay, cool. So basically, I know that a lot of folks didn't really are not super familiar with context engineering. Subagents is actually a very useful component of that. To give you like the shortest version of the importance of context engineering is that you want to be very, very careful about what you let into the context as you're working through problems. You're going to find that like, the idea of like vibe coding is just like, I'm just going to keep writing whatever I feel and like whatever I see in results and eventually get to a place where I have a working application. But then you go through the code and it's just a nightmare to deal with. You can't extend it. You can't do a whole lot with it. We've actually found that like you can actually do through the process of context engineering, be much more disciplined as you iterate through a code base. So we're going to walk through like sort of the basics of subagents and then how that relates to context engineering. And then we're going to show how to actually like run subagents in parallel. So there's two different ways. You can run them in sequence, you can run them in parallel, and then kind of go through different recipes. And then if we make it there by the end, we can go through the advanced components of this where I actually show you like some of the recipes that I literally use on like a day-to-day basis. So going into the basics, subagents are a way to like do this, what I was mentioning about context preservation. So a subagent is almost exactly like your initial interaction with an LLM, like, so in this case with Goose. That's your initial session. You're limited to like say 200K tokens, whatever your particular LLM model that you're using is. And so if you end up getting all the way to the end of that like context, usually your tool is going to compact and then you're going to lose a lot of context and then you're going to end up having to like sort of pass that on to the next session. What ends up happening is a lot of information is lost in that process. But we've also found that as you're coding and you get towards the end of a context window, it's very likely that the behavior actually shifts off from what it is that you're originally trying to accomplish. So subagents is a way to preserve your existing context by shifting it onto a separate context running outside of that one. And so here we have two different ways of like actually handling like subagents. You can do, like I mentioned, parallel execution, sequential execution. And then we also have this concept, at least with Goose, on internal subagents and external subagents. For this particular workshop, I'm not really going to touch on external subagents, but that's like, it can actually call out to say Claude Code, Codex, or some other tool and actually have it go run through an entire like subagent workflow. But For this one, we're actually just going to focus entirely on internal subagents because Goose has a little bit more control and visibility over those. So the first subagent that we're going to run, so how many of, like, I want to double check that you all have Goose up and running in some capacity. We're good. Okay. So we can actually just go ahead and like, this is going to seem extremely basic, but we're just going to run a simple file creation, but have it do it as a subagent. So we're going to go back over here. I'm going to clear out my context.
So do you
actually-
have to launch Goose command line, then
You can use it in either format. If you're wanting to be in the desktop, I mean, that's why I have both of these open. I can actually run the same prompt in either, and we'll sort of see. But initially, I'm going to run it like this, and we're going to say, I'm explicitly telling it, use a subagent to create hello.txt with hello world. And we're just going to like let that run. And we're going to see how it actually like spins up a subagent and then follows it through the entire execution.
so it's creating the subagent.
Yeah. So right now you can see that it creates this dynamic task, and then it's actually passing those instructions on to the subagent. And so what it's doing is it's actually passing on what context that subagent should actually have to go run through its entire execution. So like what I mentioned earlier about like headless Goose, you could almost think that's essentially what Goose is doing. It's just creating it's spawning a new instance of Goose to then run through that entire sequence and then return back the result to the main context. Yeah.
Just curious, like, is there like a routing system that's built in where if you're just like naturally giving it prompts, it can route and basically decide that at this stage I should create a subagent to do this, or do you have to explicitly ask it to use a subagent every time?
Really great question. So, and I'm going to repeat this in case not everyone heard it, is do you have to explicitly state this, or can it actually like sort of pick up on certain keywords to infer that you should actually be doing a subagent? And I will mention, like over here, we have this sort of in, where do I have this? I think it's later down. It's more relevant in like parallel, but we have these like trigger words that we sort of like, it would key in on. Like, so here you can see like explicit triggers where we say like, create these files in parallel, like run these things simultaneously, or run these things in sequence. So to some instances, you do actually have to like sort of mention this, but then there's like implicit patterns you see here with like a bulleted list, or you have like do X, Y, and Z. It will infer like that it should actually run these in that particular way. So
Okay.
yeah, you don't always necessarily, like I would say that if you actually want something to be run outside of the main context though, you do have to like to some extent explicitly state that. Otherwise, it's going to assume that you intend to actually just run it in your current context.
Right, okay.
And we have just under 5 minutes left. So depending
Wow,
on
that time does fly. Okay.
it does.
So we will actually skip over the sequential task because you can actually think about that as being more or less the same thing that we just did, but you can actually have it'll do one task than the next. I do want to quickly show us doing a parallel task.
So the prompt matters.
Yes. If I was going to sort of state what I think is like the most important thing when it comes to all of your different tools, the LLM, like the model that you're using, and the context are like the two most important components of all of this. So like the context is inclusive of the prompt, and so you do have to have like a reasonable prompt in order for it to work well. So I'm going to just run this one where we're going to run these. I'm actually just going to like let it run, but it's going to run these 3 different subagents. One's going to check code quality, one's going to scan for security issues, and another one's going to analyze performance.
And that agent has the insight of where the code is.
So in this part, I'm being slightly unfair here, where I didn't actually add in like what code I'm referring to. So it's just going to kind of like figure that out on its own. Yeah, in this case, we're really leaning on the model in order to actually do that inference of like, what was the intent in the original prompt. Now, normally I would recommend running this, like being much more explicit of like, because like, I know that my code in this particular directory is like 1 level up in a folder over, and I'm just going to like let it sort of figure that out on its own, see what happens.
It scans through the folders that you have on the system.
I have found with Sonnet 4 and 4.5 that it's actually been reasonably good about like this information's missing. So it'll like list the directory and see like, oh, I don't see code in here. And then it seems to go up a level and kind of like self-traverse to sort of infer what the actual goal was. So I'm going to
And-
let that run in the background.
We will let Richard get to the end of this, and then he will answer your questions after.
Yeah, perfect. So while that's running in the background, I do want to just show you these advanced patterns, and I will mention that it's worthwhile. I have a bit.ly link for all of the different recipes that I have in this workshop over there. I apologize that I don't currently have this workshop published publicly at this time because I was trying to get this finished just in time for you, and I apologize for not getting it done or through all the content faster. So this particular advanced pattern, where I think it's actually very useful for programming in existing code bases, because I think that vibe coding is very useful when you're going like 0 to 1, like totally greenfield. It can like build something out. I have found that to not work very well when you're in an existing code base. So I've actually created usually like a few different subagents, but I always have them have very specific goals and very, very well scoped. So in this case, I have one that's just a code base analyzer. All this is supposed to do is actually analyze the code base and like do basic amounts of research. This would be like something that any of us would do when we're debugging a problem or scoping out a Jira ticket is you go, okay, what modules do I actually need to go find? Do I need to trace the data flow? And it basically builds out a report to analyze all the different code patterns, file patterns, dependencies, and then bring that back into the main context. So when I'm actually trying to do, I follow a process of 3 steps. It goes research, plan, and then implement. So in the first phase, this is all like stuff, it's if you look up a talk on context engineering, I think his name's Dex Hornthy. You'll find a guy with a mustache, you can't miss it. Very, very interesting talk that actually goes through this process, and I would follow some of the other stuff that they've published. But it just does this research, plan, and implement. You basically run a bunch of subagents that go and do this code analysis and research your code base based on what it is that you're trying to like change or improve in your code. It then just builds out an entire research report that you actually like then, what I recommend is you read through that in detail. And does this make sense based on your understanding of the code base and what needs to be changed or updated? If it seems like it's wrong, you just prompt back to say, hey, these things are incorrect, or I don't think we should be changing the database schema in this way. And then you refine that. That is then stored somewhere, and that's what you feed into the next step, where you actually build a plan. So given all of this research that I've done on what I actually want to be building, go build out a plan of what we should be doing step by step. Then your final stage, and again, each one of these is starting off in a new context. This is all part of like context engineering, so that you're not poisoning or shifting the model into an area that might mislead it. The final step is the implementation step. And then at that point, when you've actually looked at the research and the plan, most of us would already have a reasonable understanding of what the code is going to look like. So in that final step, it's literally just going through that entire plan of just executing through. The other thing I would recommend is that you can actually sort of shift what models you're using if you're cost sensitive. I would use your more expensive models in the research phase for planning the research. You might use a cheaper model for running through doing the code analysis. And then you might use a slightly more advanced model for building your plan initially. And then you could use your cheaper model for doing actual implementation. We found that like you can kind of get away with that in a rough way. But that ultimately has been far more successful for us in actually building new features, and is like literally what I follow on like a day-to-day basis in my own work now. So with that, I know I only have 1 minute left, so we will go back and see. We actually had it go through and create this entire plan and analysis in parallel, and you can see that it took about 4 to 5 minutes. Or no, it's given us a breakdown. It said like sequentially that might have taken about 4 to 5 minutes, but instead, because we ran these in parallel, it took about 1.5 minutes. So you can actually see that it has an action plan of like all the different things that we can change, and security analysis. Again, these were not very good prompts. I would recommend building much better prompts and subagents that have specific tasks. Oh, and then my final recommendation for most of your subagent work I have found, don't make subagents that are going to go off and actually change things, because they're going to be doing this unobserved. And I've just not found that to be very effective. I find them to be far more effective of like, you have one that's like going to go run my unit tests and tell me like what tests are failing and why. But I don't want to have a subagent that says, does all of that plus fix the test. Because I feel like that's actually, you're suddenly asking a little bit too much of the model. You should then take whatever that analysis is, hand that into another context to actually go and fix something. Does that make sense?
Sub-agents come back to the main agent that's calling them?
Yeah, so the subagents will always return back something to the main context. So like in that instance, that's why I would have a unit test runner that's going to go run, analyze, tell me what worked, didn't work, why is it failing, bring that back to the main context, and then actually go and fix it there. Maybe it's like my own paranoia of like wanting to ensure that I have control along each step of the way. But I just find it to be far more effective, and you have like less thrash when iterating.
Templatize what you're saying, right?
Mm-hmm. You could. Yeah, you could templatize like that kind of sequence, but I find that this is just like far more iterative in like what I'm trying to like develop through the process. I know that that's my time. I do appreciate this and getting to explain this to you. If there's any other questions, I'll be around.
Cool. I have one question for you.
Sure.
So I heard you say that you helped Anthropic with the MCP, what?
Initial spec.
Initial spec.
Yeah.
Okay. Do you have any bigger flexes than that?
Well, I mean, I didn't personally do it, but I mean, like for block, that is a pretty solid flex.
It's huge.
I will say Alex Hancock on our team worked with them on the initial MCP registry and sort of curating what that experience would look like. So the open source MCP registry, block was involved in sort of figuring out how this should work. That's in part one thing that you will learn when interacting with Goose. You can install a bunch of extensions. You don't actually have to explicitly tell it to use an extension. It can infer that an extension exists that's not enabled. So it will actually search through extension. You say like, oh, hey, I need to like read this GitHub issue. And it's like, oh, I don't see a GitHub tool here, but let me go see, is there a GitHub tool installed? It will go, oh, I found one. Do you want me to go turn it on? And you go, yeah, of course, go turn it on and do that. And so that was like the natural precursor to eventually having like a centralized registry that you can then search through,
Interesting.
install tools, and enable.
Cool. Okay. So Block is doing big things, doing cool things.
Yeah.
And Richard's going to be here for the rest of the afternoon?
I will be here for a few more hours.
Okay. Let's go. Okay. So if you want to connect with him, Richard Moot, M-O-O-T. And let's give him a round of applause.
Thank you.